All right, so today we're going to be looking at law of sines and using it to find the measurement of a side of a triangle. So when doing this, we actually come up with some possibilities. So first and foremost, the first thing that we're going to look at is, let's say we're given a triangle and we're given two angles in a triangle on one side. How do we use law of sines in order to find the other sides of the triangle? Well, honestly, that one's quite simple. Because if you're given two of the angles in a triangle, you actually automatically know the third. And therefore, you have no issues whatsoever with finding the rest of the information for the triangle, finding the other two missing sides. So if you're giving two angles in one side, you can use law of sines to find the other sides of the triangle. So in this case, in this example, I have two angles, 62 degrees and 39 degrees. And I can find x, and I can also find, let's call it y, based off of the fact that because I have these two angles in one side, I can use law of sines. And so in order to do, so this is two angles in one side. So because we have two angles on one side, we can use law of sines. So what I'm going to do now is let's set up law of sines based on the information that's given. And let's solve for x first, okay? So for law of sines, you take the ratio of sine of the angle and its opposite side. So when I do this, I say, okay, what is it that I'm looking for? And I put that on top first. I put that as the numerator when I write my proportion. That's because it makes solving it easier. If you put it on the bottom, you still can solve it just the same. But I generally put it on top. So let's see how that works. So for those of you that may not remember law of sines, you can take a over sine of a, set it equal to b over sine of angle b, and so on and so forth. So we're going to do that same kind of format here. You can also switch it and put the angle stuff on top and put the side lengths as the denominator. So, okay, we're looking for x. So I'm going to do x over, well, what's opposite of x? Opposite of x is 39 degrees. So I'm going to do sine of 39. And I'm going to say that equal to information I know about. Because I know I know that I have the side length of 5.7. And I also know its opposite side. Its opposite side is 62. So this will be sine of 62. All right, cool. Well, that's pretty simple to start off, just setting up law of sines. We could even set it up for y, but we'll do that in a second because we want to solve for x first. It didn't really matter which one we solved first, but I just decided to go with x first. All right, so we know x divided by sine of 39 equals 5.7 divided by sine of 62. Okay, so how do I solve for x? How would I solve for x? How would I get x by itself? How would I isolate the variable? Well, we remember that from when we were solving equations. In order to solve for x, we would have to multiply both sides by sine of 39 degrees. And so what we would end up getting is that x is equal to 5.7 times sine of 39 divided by sine of 62. Okay? And this, we can just plug into our calculator. Use the decimal calculator if you need to. And we get 57, or 5.7, times sine of 39 degrees divided by sine of 62 degrees. And when I do that, I end up getting that x is approximately 4.1. And I'm rounding using significant figures because I was given two significant figures for the information I was given. If I needed to round out more, then I could. Okay, you get 4.06, blah, blah, blah. But that's how you would solve for x. Right? So again, we set up law of sines based off of the information that's given. We're looking for x, so I tend to put whatever I'm looking for up top as the numerator. And so I had x over sine 39, and I set that equal to 5.7 over sine of 62. And then I solve for x. All right. If you need to pause the video for now, go ahead, because we're about to do y. We're about to solve for y. All right, let's solve for y. So in order to set this up for y, there's going to be some information that we need to know. So I'm going to leave this here, but I'm going to erase the information that's given here. So to solve for y, we know we're going to take y over sine of its opposite angle, but we don't know what the opposite angle is here, do we? Well, how could we determine what the opposite angle is? If only there was a way to find out what the angle is for this triangle, because we already know the other two. There is. We know that the sum of the angles in a triangle is 180 degrees. So therefore, when we take 62 plus 39, and we end up with 101, we know that when we add the other side, it should equal 180. So we end up with that this angle here must be 79 degrees. And so I can write that in here. And so we know the angle opposite of y now. It's 79. Okay, great. So now we have all the information we need to set up law of sines in order to solve for y. So again, for those of you that may not have seen that, we know that these three angles have to add up to 180 degrees. And so if I do 180 minus 62 minus 39, I end up with 79. So that must be my missing angle, 79 degrees. Because 180 minus 62 minus 39, which were the angles given, gives us 79 left over. That must be the third angle. Okay, let's set up law of sines. So we get y divided by sine of 79 is going to be equal to, well, what was given to begin with? We could use x, but I tend to always try to stick to what was given, because that way my answer becomes more accurate. If I start using approximations within trying to solve for a missing side, I end up leaving myself possibilities of getting more error, or the answer not being as accurate as it could be. So always start with the information that's given. So what was given was that we have 5.7 opposite of the sine of 62 degrees. All right, so we have y over sine of 79, which we found the 79 based off the fact that a triangle the angles in a triangle add up to 180 degrees. And we set that equal to the given information. 5.7 is opposite of the angle 62 degrees. All right, how would you solve for y? Well, again, we know in order to solve this equation, we would have to multiply both sides by sine of 79. And so we would end up with y equals 5.7 times the sine of 79 degrees divided by sine of 62 degrees. Okay. And so if we were to approximate this, I end up with y is approximately 1.0. All right. Well, cool. Well, that is how we use a law of sines in order to solve for a missing side. The first case, at least. So, given that we know two of the angles and we know one of the sides, we automatically know that we can find the third side if we need to, or third angle if we need to. And because of that, we have all the information that we need to give relationships between the sides and angles. So we can use law of sines. So remember law of sines, you take the side over sine of its opposite angle, set it equal to another side over sine of its opposite angle. And you can do that and then use algebra techniques to solve for the unknown. And that's it. So we're going to look at another method that is used to, another way that you can use law of sines to solve for a missing side based on other information that's given. And so I'm going to stop there and I'll see you soon.